Hey guys, it's Nathan. In the last video, we started looking at map analysis. In particular, given a map to play on, we decided to focus on two simple properties of that map that would hopefully help us determine what strategy would be effective. The two properties were the amount of void terrain between your headquarters and their headquarters, and the placement and number of towers on the map. Looking at these two properties should hopefully give us a useful heuristic for how hard it is to attack their headquarters. In other words, if the map is very large, has lots of void terrain, and all of the towers are clustered around the headquarters, then you should probably go for a more defensive strategy. Whereas if the map is smaller, and there are few towers that are very spread out, then an aggressive strategy will be much more effective. In the last video, we wrote a simple function to estimate the amount of void terrain between your headquarters and their headquarters, which intuitively should give a useful idea of how hard it is to move units from your headquarters to their headquarters. In this video, we'll be writing a function to compute how well the towers on the map defend the headquarters. Before we do that though, I need to fix a couple tiny little bugs that I didn't iron out in the last video. In particular, all of these variables need to be integers, and in the analyze map function, I, j doesn't really make sense, so we need to change it to xpos, ypos. That takes care of that. So now we need to think about how we want to analyze the positions of towers on the map that we're given. So let's start by writing a new function which we'll call analyze towers. Intuitively, when is a tower powerful and hard to destroy versus when is a tower weak and not very useful? If we pull up a map real quickly, like say onetower.xml. Again, this is an old version of the map. These 5 towers aren't here on the newer version of the map, but let's just use them for now. Intuitively, this tower is very, very weak. It's far away from the headquarters and far away from all other towers. So it's fairly easy for our swarm bot to attack it and destroy it. On the flip side, these 5 towers are actually quite well defended because they defend each other. And with support from mobile units, the defense becomes even stronger. If these 5 towers were over here, we would actually have quite a hard time breaking the headquarters. Conversely, if we look at a map like rift.xml, the towers on this map are very spread out. Each tower itself is very easy to destroy, but the towers are still placed well. There's no way to get around the towers going from your headquarters to their headquarters. But, as I said before, each tower is individually easier to take on. So let's keep that in mind when we design our function. An easy way to start is just by reading the locations of all the enemy towers. I'm going to initialize a variable here which I'm going to call tower threat. The idea is that the higher the tower threat, the less likely you should be to attack. So, when is a tower actually threatening? Intuitively, if a tower is very out of the way, like the 5 clumped towers on the map onetower.xml, then the tower actually shouldn't really matter that much. Conversely, on the map Rift, all of the towers are right in the path from your headquarters to their headquarters. So one useful thing we can do to start off is check whether the tower is in that rectangle with corners at our headquarters and their headquarters. This isn't completely true, but the idea is that if a tower is in that rectangle, then we're going to have to deal with it on our way from our base to their base. So if we have to deal with the tower, then we can increase the tower threat by 1. However, we can do a little bit better. Remember that on certain maps, this should be tower lock, tower lock, tower lock, tower lock. If we look at a map like lanes.xml, we actually touched on this a little bit earlier, but towers are actually made much more powerful by being near other towers. The fact that when our units attack, there are 3 towers here to defend actually makes it much, much harder to break. So this intuitively gives us the idea that we should account for other nearby towers in our calculation of the tower's threat. So let's do that. Let's say if a tower is within 50 squared units of our tower, then the tower threat will be increased by 1. Note that the tower lock itself will be counted in this loop, so the tower threat from the original tower won't disappear. One more thing. Even though a tower may not be in the rectangle between your headquarters and their headquarters, if it's sufficiently close to the headquarters, then it still should pose a threat. So we'll add a quick check here. That says if a tower is very close to the headquarters, it will still be counted in our calculation of threat. Now we can call analyze towers here. This brings up the problem again that we may run out of bytecodes in the analyze map function. So I'm going to not worry about that for now because the maps that we're using are fairly small, but when you write your own bot, this is something to keep in mind. Anyway, once we analyze the towers, we should have a rough idea of the amount of threat that these towers pose. A higher amount of threat means that we should be less likely to attack because the towers defend the headquarters very well, and a low amount of threat should mean that it's easier to attack. Let's test this out a little bit. We're going to print out the amount of threat that the towers pose on various different maps. Oh, we have an error. This should be tower lock. This should be tower lock. So we'll run it on lanes, and we'll run it on Rift, and we'll run it on one tower. For some reason, it's not printing anything out. Oh, I see. This analyze towers and this call to print is only called once, because this block of code will only be run when isFinished is equal to false. So it actually looks like analyze towers is possibly called multiple times, which is okay because some towers may be destroyed and we may need to analyze the map again. But let's just set tower threat to 0 at the beginning of the call. Now let's run it again. So it looks like on lane.xml, okay, so I found the tower threat printed out by player A, which is 34. This isn't surprising because the towers are all in a clump right here, and they should pose a very big threat. Oh no. There's an exception. That looks like an exception in the client, though, rather than an exception in our code. The threat on this map is 6, which is much lower. Finally, the threat on this map is 1, which is lower still, because there's only one isolated tower between our units and their headquarters. So this suggests that our idea of threat isn't that bad. If there's a lower amount of threat, then we should be more likely to attack, and if there's a higher amount of threat, then we should be more likely to defend. In the next video, we'll start talking about strategies to use based on the threat we've calculated and the amount of map terrain that's void. See you guys next time.